Good afternoon, everyone. I'm your moderator of today. I'm Carlos Wen with the Department of Fashion and Image Design at HKDI. Today is the last master lecture under the theme of Swiss inspiration, Swiss design today to tomorrow. And we're honored to have Dr. Verena Ziegler with us today. Dr. Ziegler worked with the Interaction Design Department at the University of Arts, Zurich. She was trained as an architect and textile designer. She conducts research and teaches in the area of embodied interaction and computational design, with an emphasis on new materialism and post-humanist theory. In Verena's general research and various teaching formats, she explores future through practical prototyping and building of experimental machine and robots to explore post-digital sensory and embodied engagements with technologies. Her research critically investigates the collaborative exploration between architecture, textile, and interactive design, and also how we can enact sustainable form of living to create a sense of place and expression of personal, cultural, and aesthetic value while blending traditional craftsmanship and novel material. May we now invite Dr. Ziegler to begin her sharing with us today. Thank you.
Hello, everybody. So thank you for the warm introduction. I now share my screen, I guess, right? Okay. So I start straight away. So I consider my practice as being in between different fields. So I'm trained as an architect, but also I have a master's in textile design and in interaction design. I did my PhD. So I investigate materials and technologies in different constellations. And I guess I moved between those constellations a lot, between architecture, interaction design, and textile design. So from the space to the body, or from near field to far field interactions, and from body to space again. So I will, in the following lecture, kind of go through those three phases of my research. In general, what kind of is maybe the motto of my research is how do we want to live in the future? I'm very interested in like future technologies and what they might entail for new possibilities for us to live differently together, to also have a different mindset and understanding of the world that we inhabit. So how do we define our relationship with the digital in the future, but also with the material, of course? And I think one image which is kind of bringing it really to the point for me is that we are living in this kind of high industrial, high capitalistic mindset, where we kind of have the resources, we put them in our kind of machinery, where we appropriate, where we circulate, where we transform them, where we consume them, and then we kind of push them away, we throw them away, it's waste for us, and then we start the whole cycle again. And on the right downside, you see nature. Nature is very excluded from all of our kind of capitalistic ways of producing things. And I guess that is also why we have this problem that we are kind of this, letting our world die, that we really try our hardest to make every effort to destroy our world. And I try, that's also one of my really hardships, that I really try to give you an impulse to change something about this attitude. So in my research, I try to look also at nature. How is like the basic elements of nature, how does it work? And here on the left side, you can see cells. So that is a baby who is kind of evolving. And you can see in those cells that they all work together in a community, in a collective, and they are transforming with each other as a collective and building something together. And this is also how algorithms work. They are not singular, they are always kind of in a collective. They are reacting and interacting with each other to form something as a whole. So looking at those natural principles, also you can find in swarm behavior, you can find in plants, you can find also in mathematics, is, I guess, the basic principle of every living being. Because we are, when we think about it, all coming from the same substances, right? When we really break it down to a molecular level, we are all kind of built out of the same substances. If we are a plant, if we are a human, if we are an animal. So I guess this, keeping in mind, is kind of the basis of my research. Which brings me to this kind of form-finding principles I use a lot. So as I showed in this kind of picture where we throw stuff in and we kind of waste it, we usually as humans tend to put a finger on things and say, I want you to behave like that. I want you to do that. And this is kind of a one direction interaction with the world, right? We don't want feedback, or we tended in the past not to want feedback, but to predict and to conquer and to kind of manipulate and dictate. And this form finding kind of research, or this angle of looking at things, I think is shifting this mindset a lot, because there, this material component of the material itself having kind of agency, so something that is in the material inbuilt, that is kind of interacting in a certain way with me, that then together forms a different or a certain form. I guess that is what I'm interested in. So looking at this picture here from architecture, where you have this steel piece for construction, so it's holding a lot of weight-bearing things. You can see then that there's in the middle of this picture also a parametric, partly parametric approach, where there have been in the program the weights and also the strength and everything in the parameters built in, and the material qualities were also put in the program. And here you can see that the form is already shifting. And then in the last bit of the picture, you see that there were no inputs made by a human. It was only the strength and the weight this piece has to lift or has to hold were given. And then it is building its form by itself based on the minimum amount of material and the most amount of strength this material can hold. And you see this mass-produced piece on the left is 5 times the material of the one where you don't have an influence and where you let the material strengths kind of be computational computed. And you also see that it is way smaller and less material. On the right side, you can see a chair, also computational designed, and this chair is also constructed based on the weight of its inhabitant, so of the person who's sitting on it. And every chair would look differently, kind of based on the person who's sitting on it. And this way of thinking is that we as humans kind of try to also step back a little bit from our high horses and let, together with computational programs, CAD programs, or also with AI, help us try to find the best possible way that is kind of so complex that we cannot compute it in our head, but that the machine is able to do for us, and let kind of the form be guided by all the influences. So the material, the weights, all the circumstances are which are there. And the context, I guess, is that you could see those kind of form-finding principles, or also others call it biomimicry principles, by Frei Otto, for example, here in the middle and on the right side, where he was making out of soap bubbles experiments to have free structures that needed the minimum amount of material and the most amount of surface structure. And you can see also here on the left this principle that Antoni Gaudí used for the Sagrada Familia in Barcelona, where he was doing these kind of weight experiments because construction techniques weren't developed at that time so far. And he was doing with the sand weights, he was constructing then forms, and with a mirror, he was then projecting it, that it, kind of demonstrated how the building would look like in the end. So these are form-finding principles that try to let the material speak and let the material predict or guide the form. Also, Frei Otto, and on the downside, he experimented a lot between mathematical principles, geometries, and maybe famous for his world card principles, how we could from a 3D also go to a 2D structure. And this brings me to my first kind of input. So I started off that I was very interested in those minimal surface structures. Minimal surface structures are mathematical computations that you can also express in an object form, or in a drawing, or that you can visualize. And these minimal surface structures have their ability to bear their own weight, but also have the minimum amount of material with the most amount of surface structure. And it is self-bearing, so it doesn't need to get held by something. And I was experimenting first with soap bubbles, and I was building with wire different framings, and then I was just looking what forms would evolve out of that. And I then continued to also put it in, of course, Rhino, Grasshopper, so 3D programs. And I was also working together with mathematicians who construct those minimal surface structures and use them in a designerly way. And what you can see on the left, maybe I come to that in the next picture, I don't know. I do. What I did out of those mathematical formulas is that I 3D printed them. And I tried to use those structures to think of different wall systems, because I was coming from architecture. So of wall systems that could stand by themselves, that you could mount and demount, that you can modularly build together, and construct interior walls with it. And I tried a lot of different forms, and I then finally found a form that was kind of also more easy to produce. And this form was kind of that, where you could at an existing wall put just one element on the wall that would be sound bearing, and also have a kind of heat insulation and also a mold insulation. Because at that time I was living in New Zealand, and New Zealand has the second highest asthma rate worldwide. That is because of the Pacific climate, but also because their houses are built very fundamentally or basic, I would say, without any insulation systems, or at least the old houses. Now they, of course, have also in the new houses these things. But the poorer regions where also a lot of like not so well-educated people are living in New Zealand, they are really struggling with getting their houses dry. And therefore I was thinking of a very cheap and easy to produce modular system they could attach to already existing walls, or where they also with 2 elements can form new walls and put also insulation inside of it, and electricity and things like that. And as New Zealand is a land of wool, I first tried it out with wool, but the hemp one, hemp was then the better choice because it was a bit stable, more stable. And what I showed in this picture here is I used a heat compressing system you usually use for the car industry to do these interiors that are very thin from the material. And I used an epoxy, a sustainable epoxy resin to then kind of in this heat compression procedure produce those lightweight elements. Yeah, that was one thing I did. And I was then more curious, how can we think even more extreme than that about natural principles and how we could engage with them? So a long time ago, we started the Wunderkammer Lab. So the I don't know if you know the term Wunderkammer, but it was associated when there were no distinction between the different sciences and the different disciplines in the medieval ages, that they had this curiosity cabinets of things they couldn't really distinguish or put in categories from, like sea monsters or different forms of shells. And yeah, so they had these kind of curiosity cabinets, and we were influenced by that when we built our workshop. And what we did is that we built a kind of new curiosity cabinet where we had a lot of different materials, a lot of different techniques, I would say, and substances. And we experimented very freely with matter, I would say, with materials. Here, for example, you can see flour, and you can see that it is sound who is influencing how the flour kind of behaves. Yeah, so we were very interested in what will happen when we really just play with materials and see what is happening. And we had also a lot of inspirations from nature, and then kind of developed first prototypes in this project. And that made me curious because I thought, wow, it's so unforeseeable what is coming out of that. And that's such a wonderful thing to not always predict the form and fine tune everything and do the 100th poster, but to really dive into something that is, yeah, kind of exciting. So I then started my PhD, and I had the possibility to get into this topic more deeper. And I had the chance when the Open Innovation Lab in Konstanz opened that I could join this lab. And there I had the possibility to work in a digital kind of fabrication laboratory for interdisciplinary research between the different faculties there. And on the wall on the bottom, you can see some of my research that they then also exhibited a bit. But what I want to say is that I had the chance to work together with different disciplines, and they gave me the chance to write different projects, to make different projects up and find people who were working with me on them. And one project I wrote down was that I wanted to develop a candy floss machine, but a candy floss machine not for candy, but for plastic, for waste of plastic. Because what I found out is that plastic, when it is getting melted, has the same kind of behavior like sugar when it is melting. And there's still this problem of that you have to distinguish plastic into the different sorts, that you can't mix them usually once you want to recycle them. And with this procedure, it is naturally sorting itself out, because the different melting temperatures of the plastics, they then connect with each other at a certain point, and the others a bit later, the others a bit sooner. And so it's sorting out itself once it is getting melted together. So I found a student in the mechanical engineering department who built a candy cotton or a plastic cotton machine with me. So we did a lot of experiments, which were also, I still have burn marks from them, I guess, from the plastic that is getting melted. And we did a lot of experiments with like pans where we put holes in, where we then put hot plastic in it. And we ended up building a very professional machine, I would say. So our poly cotton candy machine, where we had then the possibility to create a kind of a new lightweight material that is similar to the bone structure. So it has a lot of weight bearing functions, but it is also very stable. And you can also compress it like in different forms. So it is always depending on the form, like the different waves you press it through with, like the candy floss machine. It's the same, that you have like different sets of filters where you can put the material through, and then it's depending on how the final form will look like. And we did that with this machine as well. Then I had the possibility to make another project up, and I thought, okay, it is kind of interesting that those 3D printers, that they are usually limited to, I don't know, 40 to 40 centimeters or 60 to 60 centimeters. And then there is a huge gap. And then you have these big professional 3D printing machines that fill rooms and take for days. So I contacted Zünd, which is, I guess, one of them, famous cutting plotter systems worldwide. And they are interestingly have this kind of modular system where they have like these different plugins you can adapt to those machines. And I thought, why not just make a plugin to make out of a cutting plotter a 3D plotter? Because that would be just, very easy to do. So with an electrical engineer together, we built our first prototypes. I was very interested in building a 3D printing on fabric. So we put like on normal printers fabric on the base, and then we put like the normal filament material on top of it, and based on the different forms we 3D printed it with, then different forms evolved out of it in 3D. So here at the time I was also reading Ornament and Prime from Adolf Loos, He was an architect, and he said that in the Renaissance or in the Jugendstil time, that these ornaments were kind of a crime because they are not showcasing the real substance of the building. They are kind of a fake thing on top of it to make it pretty. And he was arguing that the form should always also entail its function, so to say. There were a lot of those later on in the Bauhaus and in the Ulm design school, who then also followed this kind of this momentum that the form should always follows the function. And I wanted to combine that the material and the form should be out of the process. And that is why then we built first prototypes with these kind of machines where we put like 3D printing devices on it. And what I wanted to achieve is that I built a kind of, again, a modular wall system for the interior, where you can just print all the clickable systems together, and that you can combine without any construction behind it, so that it is self-bearing. And it didn't really work out the way completely I wanted it to be. You can see here on the top, it's kind of sticking out a bit. I did a lot of experiments with different forms and different behaviors, but I couldn't figure out what is exactly it that is influencing the final form, and how can I also computationally predict that form beforehand. So as I did those experiments, I realized that I need more research that is on the computational side of things. And here you could see what I had in mind to produce. So I first wanted to have this top layer, which is the 3D printed fabric. And then I wanted also to have conductive ink printed on it, that you can have like electricity connections and things like that inbuilt. And I wanted to have also an insulation layer out of wool or hemp or out of fungus material that you could put between the two layers that you click together. And then I also thought about, again, like coming from this New Zealand approach of a mounting system, that you can also only take one system, like one element, and put it on existing walls. But I needed to do more like research to predict the form before printing. So I tried to do that with Rhino and Grasshopper programs from architecture. And it kind of was difficult for me still to predict forms based on those computational methods. It was very interesting what I found out, and I'm glad I did it this way, but I knew that I couldn't get further in that. So I then did my last project together with the computational design department. I first started off doing like mathematical minimal surface structures, and I realized, okay, mathematics is great, but I need also these computer scientists who help me, because it's not mathematics alone. I need kind of machine learning for it. And I then did my last project description for like students, and I had this team project, and I was asking for a simulation to simulate how fabric in combination with 3D print, so filament, would behave beforehand. And so I found a group that was very interested in this university, and they kind of helped me a lot to progress with that. So they would, together with me, constructed a program where you can simulate, once you print material on, that you can also simulate how it would like interact in 3D, and how differently it would behave. Based on that, we then developed a kind of simulation program to test how 3D print would work, basically, and how you would arrange the 3D, the filament on the fabric, that it creates different forms. So I now, not to get boring, want to dive into another angle, enough from architecture. We then, from the University of the Arts Zurich, where I was at the same time where I was doing my PhD, still teaching and researching, we got the offer from the ZHAW Winterthur, which is the mechanical department, to help them with basic research. And what you can see on the left in this little picture is an exoskeleton that you use when you have, for example, a stroke and you can't raise your arm anymore, and they want to help you support this arm, that you can train this arm or that you can raise the arm. But what they found out is, as mechanical engineers are, they build everything super strong. So the thing is weighing like 15 kilos. And imagine an elderly woman who had just a stroke wearing a 15-kilo piece of exoskeleton. So they asked us to work on a kind of material experimental approach. And we then first through drawing, first through prototyping, tried to find different behaviors of like how you have to raise your arm. And we found out that you nearly can raise the arm 360 degrees. So it's the most moving part of the body. And then we thought, okay, we have to take a material that is close to the skin. So we chose to use silicon. And we also had a look at natural principles again, how, for example, a worm is moving, or how origami structures or folding mechanisms work. And we then found out that the material we want to use is a combination of coffee ground, because coffee ground has a bigger surface than it is its weight. So once you suck out the air out of coffee ground, it is kind of connecting with each other in a very strong way, and it is very stable. And once you push air into it, it is then again floating freely. So what we did is, in the end, that we filled in those silicon tubes coffee ground, and we put a little tube in it, which is sucking the air out and in once the person wants to raise the arm and not. So it is feeling soft and warm, the material, like silicon is. And once you want to strengthen the arm, it is then also behaving like a muscle and lifting with you the arm. What I also want to say as the last step is, as you can see, I slowly moved on from architecture to more bodily approaches. And I was interested in how we could interact, not just with architecture, but in between the built world and the human body. So I did research with a friend together, Alicia Welaquez, where we kind of also very low prototyping experimented how we could differently interact with the world with our body, and how we could also maybe more humanly or more on a bodily base interact with our environment. And what we wanted to do is that we have this kind of bodily perspective to the world, and it kind of shifted also my perspective, that I recognized that I am not anymore so interested in architecture, but that I am more interested in how we interact with the environment, with our body. So we did also a lot of weird experiments with form-finding principles, with clay, and with this kinetic sand and 3D printed forms. But out of that sprang something that is now my business today. So I kind of took it further and tried to explore this bodily perspective to computational design. I have to look what time it is. Do I still in time? Yes? Okay.
Yes.
Yeah, good. So what I did with my students then is that I kind of 3D scanned them with a Kinect, and that we then kind of thought about the prosthetics approach of thinking from the body to the environment. And so I used an architectural program to do something very related to the body. And we experimented with it. And then I kind of started my project from that course inspired. And I researched into how fashion actually evolved over the last 160 years. And I found out that fashion, in the very, very basic sense, like sewing patterns, hasn't evolved at all. So we are still in the same process since 160 years, when in the first industrial revolution, a sewing pattern got standardized for mass production. And I realized, okay, there's something really, really wrong with that. And the human body is 3D and not 2D. So there's one dimension missing. And I found out that this fashion industry is the second highest polluter worldwide, because you all probably know it. A lot of clothes are getting produced in standard sizes, and then they get produced in advance, and the stuff that is not getting sold is sitting in shelves and then is getting is getting sent back. It's getting destroyed, usually, because it is cheaper to destroy it than to resell it again. So I did a lot of prototypings, very basic prototypings with 3D scans and myself. And I was trying to find out how we can construct something directly from the body, a sewing pattern that is not missing this third dimension. So again, I did in Rhino first tests and tried to find ways how to mathematically unroll surfaces. So a three-dimensional form, you can't put it flat in 2D. That's a mathematical problem. And but there are ways around it. So if you have a doubly curved surface, so like this, then you can't unroll it into 2D. But if you find ways to have a single curved surface, then you can unroll it in 2D. So the challenge was to find computationally the lines where you can divide pieces into 2D that still represent the 3D structure. And out of that, we kind of experimented different inputs. So we said, for example, I want no waste, please do kind of Voronoi structures that are evenly arranged over the body, or I want no straight lines, I want only horizontal lines, or whatever we kind of gave as input. Then the computational computer simulation divided the body into those different segments. And we did a lot of experiment with heat maps, and then we started cooperating with the ETH in Zurich and the university I did my PhD in. And we trained a machine learning system to divide the body into different segments that the computer really knew, hey, this is the left shoulder, and this is the belly button, and this is the nose, and things like that. And we also did fabric simulations. So we developed kind of a computer program that also had fabric e-module values included. Then, this is my daughter, we scanned different people, and we kind of developed out of a 3D scan with machine learning, with this trained model, a system that we can, from a static 3D scan, can generate movement on an avatar. And with this movement simulation and with this material clusters we put in our library, we could kind of directly on the body create garment shapes. And what I found interesting, or what I found eye-opening, is that a static position of a 3D scan is not representing how you move in a piece. And this movement-based sewing pattern design is not explored worldwide yet. And with this program, we could first start to see how, with different movements of raising your arm, lifting your shoulder, different needs of the fabric would evolve. And so we experimented with that a lot. And then I realized, I also wrote a patent then about it. Then I realized, okay, the industry, the fashion industry, they are not there yet. They are still stuck in, like, I don't know, 150 years time back. And they don't have this thinking that they want to produce better. They just want to have less returns, and they just want to have more profit. That's it. So for a business model that I then developed, I used the 3D scanning technology we developed, that you can scan yourself with every device, like every camera you have, like tablets, laptop, smartphone, desktop. And that you just stand in front of your camera and you turn 360 degrees in an A position, like your arms a bit stretched. And then we create an avatar from you, and then create a size recommendation for online shops. That was then the first thing we tried to enter the market with, to kind of take the people where they are at the moment and try to help them fix their first problem, the high return quotes, but then to also show them through data from the 3D scans, hey, you have a customer clientele who is scanning themselves and they don't fit really into these standard S to XL sizes. And it would be great if you either have a size in between, or you change your size systems, or you also develop a kind of capsule collection that is on-demand producible locally, for example, for customers who are having different body shapes, because only 30% of the population fit into standard sizes. So 70% of us have fitting problems with standard sizes. And the industry is not realizing that, really, I have the feeling. And so I guess our way now is to kind of make people aware that there is this problem, that they have potential customers who want to buy, but they can't buy because it is not fitting. And then to offer a solution for that, to produce in microfactories on demand locally, those individualized sewing patterns. And what you can see here in those experiments we did is that no one is symmetrical. So also all design programs you have worldwide, there's no design program who can do asymmetries. But every person is asymmetrically. So you see, there's such a huge gap between reality and a mass standard kind of capitalistic system that is kind of causing this huge problem of the waste and of the toxic production cycles in fashion. And we wanted to kind of create a system where we slowly transform from this kind of standardized production way to a more on-demand production way. And I'm not sure if you are aware, but there are coming, at least in Europe, new rules by 2025, where they have to track CO2 emissions, where they have also track material waste and things like that. So the industry is really desperately looking now for the first time, because if there's no rule that I can do whatever I want, for the first time to get more sustainable. And it is funny that they haven't done really a big effort so far, because they weren't forced to do it. So what we realize is also through the war in the Ukraine and through COVID that those Lieferketten, what is it in English? That to get the stuff produced in Bangladesh and wherever they produce to Europe was very broken down at a certain time. And they started to rethink, oh, okay, wow, we don't have any resources in Europe so far anymore to produce, and we don't have any infrastructures. We are completely dependent. It's the same with energy anyway, too. But anyway, so they are now starting to shift their thinking, that they also have these kind of backup microfactories starting in their kind of backyards, where they start if like the mass production stuff is going out or is not there or not available, they start to produce in their backyards the clothes themselves. So I guess it is an interesting movement at the time, at the moment. And one last thing I wanted to show you, and then I'm done, is that there's also a huge group missing, which we don't consider in our population at all. And that is people with disabilities. So for example, with ETH, we wrote a paper about this, that, for example, Sophia, she is, how do you call it, little people? I don't know. She couldn't wear in her life a skirt because she has to raise her foot 90 degrees to climb a stair. And for her, we, of course, then also used our trained system to move her avatar in different ways to simulate that she can also can wear a skirt. And she was, of course, super happy that for the first time she was able to wear something like that. As you can see here still, those sewing pattern lines are very experimental. We are now at a very different state. But I guess for just showing you the possibilities that come through such an approach, I guess that's enough to show. So the last thing I wanted to mention is that we also did a lot of crazy stuff. Like, for example, here, we cloned a kind of, from Alice in Wonderland, these fantasy persons. We cloned them together with Buddha-like figures and try to combine it with a human body. That is my other daughter. And we created then a kind of garment out of those personalities, so to say. And that is bringing me to kind of the future. That is, how also do we want to physically engage with digital realms, with digital worlds? And how can we still try to stay human in it? And I guess that is really a challenge that is coming the next years or time ages, that there's still a huge gap between virtual worlds and the physical worlds. And maybe fashion could be a way to combine those worlds together, that you have an avatar where you are digitally in the metaverse, or whatever system we will have in the end, can interact but also can wear things you've designed maybe there in the physical world. So yeah, I think I want to end with that. My movie is not playing, that's funny. It's too big, huh? I don't know. So you can also see that movie on the website, beaware.ai. So that is my business now, that we create kind of size recommendations with avatars. We also do virtual try-ons, and we also do on-demand sewing patterns for small batch or for on-demand productions in microfactories. So thank you for your attention, and I hope you had fun. And yeah, I'm open for questions.
Thank you, Verena. It's very interesting sharing. I think I learned a lot from your lecture just now. Well, I'm going to open the floor to questions, but I feel like I've got questions I want to ask. For your company, Be Aware, how do you see your next step? What is your vision for your company?
My vision is that we are working on developing a first microfactory in Germany, and also we are in a bigger network in Germany where they are transforming a whole area of Germany, because we were in what is it called in English? That's a good thing. Diepel, please help me. They are Braunkohle. Brown coal. Okay, it's nearly the same. They are now getting out of this brown coal mining, and they have like really millions of workers, places to fill, and they are building huge microfactories, starting to build huge microfactories in Germany, and we are part of this network. So our vision is to have a kind of decentralized network of producers worldwide that can produce fashion on demand, but also to enable smaller companies or designers that they have now this kind of high technique they can't really do by themselves to construct a sewing pattern really the best way, that we help them and that we give them the tools as in the maker community, as with the digital 3D printing, to give them tools to easy access, and then be able to become more independent and create their things, and don't be dependent on only those huge factories and brands anymore. I think that is my vision, because I guess I just read an article this morning that we are really fastly destroying our world at the moment, and the only thing that would help is to collectively work together and try to change transformatively our way of thinking. Yeah,
I agree 100%. You know, the whole decentralizing, you know, how fashion as a business is so damaging the world in general. I think decentralizing is a good tools and a good method to get to that stage, and how we could give ourselves back to the community and to engage with those little community. I think it's a great vision and a great company that you're working on, Verena.
thank you.
You have a question on the floor. So I've got Eric asking you a question. So the question goes, could you share with us the biggest challenge you have experienced so far on your design work combining digital into more human fashion design?
I'm not sure if I get the question. So I mean, I'm facing all the time a super big challenges because I'm doing something that is not in line with our capitalistic thinking. But combining digital into more human fashion design, I mean, at least in Germany, we are very concerned with our data rights and data issues, and security is very important. So people have, of course, concerns when they when they deliver 3D data of them. So we were working a lot on those kind of security issues, that we cut off the head, for example, that we developed also a gamified system that you can playfully, like in these emojis, that you can put a head on yourself, and then you can design your head how you want to look like, but the body stays the same. So it's your body. That is one big challenge. And then also, I guess what is really challenging is to make people, and especially companies, aware that they can't proceed in the same manner anymore. They have to rethink how they are producing their stuff. And of course, they want to proceed in the same procedure as usual kind of way, and they don't want to change anything. So it is hard to find like digitally aware people that want to transform and change something, and that are also aware of like the impact such a new movement can have. So yeah, but I'm fighting on a really lot of fronts. If that's what the question.
Right. You know, personally, I'm also very interested, Verena, because I know you were trained as an architect to start with. What drove you into textile and fashion?
Because architecture is very rigid and very fixed. And I think it comes also from this, especially in Europe, this thinking we want to prolong our little living beings, and we want to make something for like endless times. And I think the world is in constant flux, in constant changement. And I also realized that architects are not that much interested in people. So they are not really designing for them. They are more interested, as you also see in architectural pictures, usually the people are maybe on the side, or, you know, it's more important to have this monument of building. And I don't like this attitude. So I was more interested in processes and in change, and what could evolve out of things that transform over time. So yeah. That's
great. That's interesting. I agree. I agree 100%. You know, sometimes working with different people is definitely a lot more welcoming than working with materials in a way, or buildings. We got questions coming in from James. So James goes, the last part is very interesting. You have showed a very interesting way to measure the human body and producing a dress. It is very exciting that it will allow you to design and produce a dress or costume without any sewing knowledge, and completing all of the calculations with computing and AI. And do you think it will be a big threat or tool to the fashion designer? And he also said, I'm not a fashion designer, but it seems like you did a great job with it.
Yeah, I do hope that it's not a threat to fashion designers. I think that usually fashion designers themselves are not always technical sewing specialists, like sewing pattern developer specialists. So I guess for them, it would be a tool to really make their fashion design come to life also in a technical way of production, because we can automatically arrange the sewing sides and points, and we can also name them, and with if you put like in a microfactory a cutting plotter into the microfactory, then it is only a room where you have a cutting plotter and a person who's sewing then the cutted piece. So what we do is that we create a sewing pattern based on a 3D scan, and maybe in a microfactory shop you see like your avatar, and you can put on different clothes, and maybe with a scanner then hold those garments to the scanner and see them then projected, and can change things on your own, and then you can kind of send it to the cutting plotter. It's cutting it out, and then the cutting plotter has also the possibility to make marks. Hey, sew this with this and this with that. So I guess it is more this kind of maker culture to enable. We don't want to threaten someone, but we really want more to enable, to overcome this big hurdle and make it more accessible. Yeah.
I also agree it is a tool to enable us to work more efficiently in a way, because, you know, when you develop sewing patterns, it's actually wastage, because at the end of the day, you probably throw those paper away. And
Yeah.
developing samples is also another source of wastage from our industry.
Exactly, yeah. And also creating a sewing pattern, it's not just once done, right? You have like different iterations, and you have to redo it, and then you have to unroll it again in 2D and reconstruct things and parts. So like really basically not rearranging parts of the sewing pattern, but completely from scratch developing a sewing pattern is a huge and long time process. And we do that in 3 seconds. Yeah, so I hope that brings the point across. Yeah.
Yep. You know, also, you were mentioning about 3D printing at some point in your lecture, which I find really interesting. And then I have the thought of, how do you see 3D printing and its future? Do you see it being one of the most commercialized tool going forward, because of how how enabled it is and how easy it is to work with?
I think so, yes. Yeah. So I mean, we are starting to also print houses, to print concrete, to print metal. I guess what is still the issue there is that it's usually a layering process. And for some systems, these layers are not stable enough. So because they are not a compound system where it is like completely anchored with each other, it's only on the top melted to each other. It is sometimes not as strong as other processes. But I think that the more techniques are getting developed to maybe also print in different ways, the more accessible it will get, I guess. Yeah, definitely. And I mean, you only print what you really need, right? And it's not such a waste of material.
Yeah.
Yeah.
I've seen, articles saying you could 3D print a gun. Do you see we could 3D print fabrics and a t-shirt in the future, in the near future?
Yes, yeah, definitely. I also have a friend who developed a system already for that, and it is kind of injecting fibers in a process where you kind of knit even, or kind of make this weaving layers with the injecting needles, and it is only printing the material on the places you need it. And you can also put, like, for example, polypropylene or other materials and kind of heat glue them together, that you don't have to sew it anymore. So there are a lot of things who are evolving, but I mean, that's really future technologies, and I'm not sure, because our tradition of creating fabric is so elementary to how we perceive us as humans in the world. I'm not sure how long it will take to get to this level, to be honest. Yeah.
But it's good, at least we see some lights in the tunnel. It could be,
yeah, definitely.
I feel like it could be a way merging the two, so your 3D scan and then directly have it print as a garment. So that would
definitely
reduce a lot of wastage.
Yeah, yeah. I post the address of it, that you maybe can have a look at the site, because it is really interesting what Peter is doing. And there you kind of can see what this machine looks like. Can I put something in the chat?
Yep. Oh,
and I also do get you the right link to the there's also a direct link, I guess. Yeah, learn more. I can't find the direct link at the moment. Yeah, but if you look at the website, there's also somewhere a link to the project where you can see the machine.
Interesting. Thank you. Thank you for sharing with us that information.
Ah, here it is. I found it. Now you.
Okay.
So that is the direct link.
Ah, okay. Got it.
Yeah, and it's really funny because there you can see also that it is, of course, then important that you have different sewing patterns that are more like in one piece. So it's also creating different different structures of maybe how we design things in a certain way. So yeah, but yeah, that's just a kind of a future vision.
Thank you, Verena. I don't see any more questions, and I think time is almost run out. But again,
Yeah.
thank you very much for sharing. I think we all learned a lot throughout your sharing, and
Thank you for having me.
I love it a lot. Thank you.
Thank you. Have a good day. Bye.
Have a lovely rest of the day. Bye-bye.
Bye.
Bye.